In today's lesson, we are going to look at T formula. So where can we use T formula? We can use T formula in integrals that are in this nature. 1 over a plus b sine x plus c cos x. So this is a general form of the type of the integral where we will need to use T formula in order to integrate. So first of all, you need to know the formulas that can help you to integrate this type of integral. So we are going to derive them, then we will look at an example. So firstly, when we derive them, it is important that you know how to derive them in case you forgot the formulas. So it's T is equal to 10 x over 2. I can solve for x over 2 here by taking the inverse of tan t. Then I can solve for x by saying that now it is equal to 2 arctan t. Then if I differentiate this, differentiate x with respect to t, dx over dt, 2 is a constant. Differentiating arctan t, we know that it's going to be 1 over 1 plus t squared. Then we can solve for dx alone, make dx to be the subject of the formula. Then we will have 2 dt over 1 plus t squared. So, okay, it means that this integral here, it contains a sine and a cos. So we need to be able to solve it. So first of all, we need to start from here. If we have a triangle like this, and then we say our angle inside is x over 2, and then we have said that t is equal to tan x over 2. So this is actually t over 1 is equal to tan x over 2. So we can put t here because we know that tan by definition it's actually opposite over adjacent. Then how about if we want to find now cos of half of x over 2? It means that we need to find this term here, and this is simply going to be 1 plus t squared, because by Pythagoras we will have 1 square plus t square. If I let this side to be r square, then solving for r will give me the square root of 1 plus t square. That is by Pythagoras theorem. So by definition, we know that cos is actually adjacent over hypotenuse. So adjacent over hypotenuse, the adjacent side there is 1. The hypotenuse is square root of 1 plus t square. Then again, sine x over 2, it's actually going to be opposite over hypotenuse, which now is going to be t over the square root of 1 plus t squared. So, okay, we can see that in this integral here, we do not have x over 2, but instead we have x. We have sine x, we have cos x. So, but we can find from here we can be able to find what cos x is equal to and what sine x is equal to. We need to be aware of this identity now, that cos 2x is actually going to be equal to, this is an identity, cos squared x minus sine squared x. This is a trigonometric identity. So meaning that here we are having cos 2x, then this side, now the angles are halved, and then it's a square, they are squared, and then the cos is squared and the sine is squared, but now the angle inside the cos and the sine, they are actually halved. So meaning that if I have cos x, I will have it to be equal to cos squared x over 2 minus sine squared x over 2. So from here we can continue. So we had cos x is equal to cos squared x over 2 minus sine squared x over 2. And then let's just, for reference, let's still have our triangle here. We said here it was 1, here it was t, here it was 1 plus t square. And then we said that cos x over 2 is 1 over 1 plus t square. Sine x over 2 is equal to t over the square root of 1 plus t square. So we want to find the value of cos x. Now cos x, we can rewrite this now as cos x over 2 all squared minus sine x over 2 all squared. Then we can substitute for cos x, we can substitute that. It's going to be 1 over square root of 1 plus t square all squared minus t over the square root t square. Then simplifying further, 1 square is 1, the square root of 1 plus t square is going to be 1 plus t square minus t square over 1 plus t square. So we can see that we have a common denominator here. Then we'll have 1 plus t square, 1 minus t square. So meaning that if you are dealing with this type of integral where you see cos x, you are going to substitute this value here. So let's see what sine x will equal to. How can we find sine x? Sine x, again, we have to find it by an identity. We have this identity, sine 2x is equal to 2 cos x sine x. This is a trigonometric identity. So, meaning that if I have sine x instead of sine 2x, I will have 2 is still there. Now the x is going to be halved. It's going to be cos x over 2 times sine x over 2. Then from here, we can say that sine x is equal to 2. So, okay, cos x over 2 is this. So we substitute 1 square root of 1 plus t square sine x over 2 is that one there, so it's going to be t so now we have 2t over 1 plus the in the denominators we have the square root of 1 plus t square and 1 plus t square. So this, the square root, they cancel out there. So this now is the value of sine x. So from here we can be able to look at an example. So some students, they can cram that cos x is equal to this and sine x is equal to this. So this derivation from here and using the triangle is very important if you want to remind yourself. But if you are good at memorizing, you can take them from here. You can take them from here if you know that, you remember that cos x is 1 minus t square over 1 plus t square, and then sine x is 2t over 1 plus t square. So you can be able to just use it like that. So let's look at an example where we can apply this. So we are having an integral of dx over 5 plus 3 cos x. So in this example, it is going to be a little bit easier. We won't have a lot of solving because we only have cos x. So here, we said that cos x is equal to 1 minus t square over 1 plus t square. So it's 1 minus t square over 1 plus t square. So that is the value of cos x. And then what did we say dx is equal to? dx is equal to 2 dt over 1 plus t square. So it's 2 dt over 1 plus t square. So let's just confirm this. It's 2 dt over 1 plus t square. So that is the value of dx. What we need to do now is to come and substitute into this integral. So it is better to substitute here for the purpose of easy simplification. I will substitute dx here as 2 dt. I can write it like this, or let me write it properly, because I know some people can be confused when it's like this. I'm having it like this now: 1 plus 5 cos x, then dx is here. So I will have 1 there, 5 plus 3. The value of cos x is 1 minus t square plus t square. There is a reason why I want to write it like this. It is easily simplifiable when it is in this nature. So what we need to do is to work out what is this side first. So we can work out that here. If we take this denominator and multiply that side, we will have, it's going to be 1 over 5 plus 5 t square plus 3 minus, it's going to be minus 3t square over 1 plus t square, and then times 2 dt over 1 plus t square. So now from here, this one and this one, it's allowed to cancel out. We are not supposed to cancel it from here. It will be mathematically incorrect if we did it like that. So from this step, we can be able to cancel that out. So now when we continue with our problem, now it is going to be 2 dt. We can write it there now. Then we look at the like terms from that denominator. We'll have 5 plus 3 is 8. And then 5t square minus 3t square is actually going to be plus 2t square. Then from here, now this, it's going to be, we can see, if you are able to look closely, you'll be able to see the answer from now on. Now we have 2 dt here. We can factor out 2 in this problem. If I have 2, then I will have 4 here plus t square. Then this 2 and this 2, they cancel out. Then I will have integral of dt plus 4 plus t square. So I know that 4 can also be written as 2 square. So you will see why I have to write it like that. We have 2 square plus now t square. So this integral, we are familiar with it. It is the same as this integral here. Integral f of x over a square plus f of x square dx. This is equal to 1 over a arctan f of x over a plus c. So even here, we can see that now in this case, our a is equal to 2. Then we can say that maybe our f of x, it's actually going to be f of t, but let's leave it as f of x. It's just going to be t. And we can see that f prime is just going to be 1. So we can, from here, we can just easily say that 1 over a is just going to be 1 over 2 arc tan t, f of x, it's t, then over a is 2, then plus c. So because we were working with x variables, we need to substitute back our values. What is the value of t? From the beginning, when we started, we said that the value of t is actually tan x over 2. So now we need to substitute the value of t. So it's going to be arc. This is tan x over 2, then over 2 here, plus c. So that's it. We have solved the problem where we are actually dealing with the integral of this nature. So let's look at another type of integral that involves t formula. So again, now if we have integral of this nature, we have a plus b sine squared x plus c cos squared x dx. So it means that now instead of having sine x and cos x, we are having sine squared x and cos squared x. So when it is like this, the derivation now, t is no longer equal to tan x over 2, but it's actually equal to tan x. So there will be a slight difference. So meaning that if I solve for x, I will have arc tan t, and again if I find dx, I will just have 1 over 1 plus t square, just like that. Then I will have my triangle. Now it's just going to be x, and we say that it's equal to t, and then here we have this. This will not change, it will still be 1 plus t square. And then again, when we solve for cos x, we'll find that it is adjacent over hypotenuse 1 plus t square. When we solve for sine x, it's going to be t over square root 1 plus t square. So this is good enough. We can look at an example. These are all the information that you will need to have in order to solve the integral. So if we are having dx over 1 plus 2 sine squared x. So we have said that, so to make our life easier, we can write this like this. 2 is a constant, sine x, then sine squared x can be written as sine x all squared, like that. Then we'll have the dx there. This now will equal to integral, it's still there, 1 over 1 plus 2. What is the value of sine x? The value of sine x is t over the square root of 1 plus t square all square. What is the value of dx? The value of dx is 1 over 1 plus t square, like we did in the previous. So we need to solve this first. When we solve that, mostly all of these questions, all of these problems, they work out the same. We need to deal with this first, then don't cancel immediately here. Deal with this first. Then we can have it like this. It's going to be 2 over t square over 1 plus. Now the square root on the denominator there, it will cancel out. So this is actually dx. It's going to be 1 dt, 1 dt, 1 dt. So I need to have that dt to show that I'm integrating with respect to t. So now I can solve this part. So we have 1 over, it's going to be 1 times 1 is 1, 1 times t square times 1 is going to be t square, then plus 2t square over 1 plus t square. Then this is just going to be dt, 1 plus t square. Like I've said, Now this we can cancel out. We are allowed to cancel that mathematically. It's mathematically correct. Then continuing with that, we'll find that now we have the t over, we look at the like terms. We have 1 plus t square plus 2t square. So 1 does not have a friend, but t square and plus 2t square, it's actually going to be 3t square. So what are we having here? We can see that these integrals, they lead us to use this formula, but there is a way in which we can work out that. So we need to see that if we are having this formula here, dx a square plus f of x is equals to 1 over a arctan f of x plus c. So what we need to see, we need to relate that with this. So we have a is equal to 1, then f of x according to this formula will be square root of t, so that when I have f of x all squared, it will just go back to 3 plus t square. So f prime, if f of x is equal to square root of t, then f prime is actually going to be square root of 3. Then from there, because I don't have it on my integral there, I can introduce it. I can put square root of 3. Now I have dt over 1 plus this. I need to write it like this also, t like that. This is not necessary because we know that 1 square is just going to be 1. So because I've introduced square root of 3, I need to cancel it outside the integral. So now I am good to use that formula. So I will have 1 over 3, it's a constant. Then my a is just 1, so it's just going to be arctan, my f of x is actually square root of 3t, my a is just 1, then plus c. Then from there, what we need to do is to substitute back the value of t, which is this one here. We need to make sure that everything is in terms of x at the end. We have 1 over square root of 3, then arctan square root of 3. We replace t with tan x plus c. So that's it. We have successfully used the two formulas that are necessary for us to integrate with the t formula. Thank you for tuning into the channel, and please like and subscribe so that you can be notified when I upload more content. Thank you.